નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Standard 10th, Subject Science, Chapter 10, Light, Reflection and Refraction. Dear students, today we will learn the laws of refraction of light. What is the law says? Law number 1. Okay, rules number 1. You know that the incident ray, the refracted ray, and the normal to the interface of two intertransparent media. See, again I will tell you, the incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of the incidence all lie in the same place. See, now try to understand. So this is the incident ray, and this one is the refracted ray, and this one is the normal. At the point of incidence, all lie in the same plane. So this is law number 1. And second law says that the ratio of the sine of I, the ratio of the sine of the I, a sine of angle of incidence to the sine of the angle of refraction. See, the ratio of the sine of the angle of incidence and the sine of the angle of refraction is a constant. It is a constant. This is the second law. There is also called as Snell's law, very, very important one. So sometimes in examination asking, what do you mean by Snell's law? Okay, SNE, double L, Snell's. Okay, very important one. Okay, now try to understand here. The Snell's law is for the light of the given color and for the given pair of the media. So, okay. If I is the angle of incidence and R is the angle of refraction, then if I is the angle of incidence, then R is the angle of refraction, then sin I is equal to constant. So this is the second law it says. So here you not to find this. See, look here now the angle of incidence and angle of refraction. This ratio here you no need of finding the ratio. You have to find the value of the sin I. But dear students, you not to worry about that. Why? Because in the 10th standard only derivation you have to remember, not to go for solving the what we are saying, solving the problem, not that regarding this. So sin I, but the value of sin I you have to do. Sin Y means where you have to take in. So you know, learn that in the trigonometry, you know, sin I, sin theta, cos theta, and tan theta, this all already you learned. Okay, but this sin I value you have to take here. But that you will learn in the 12th standard, not now, only just for understanding it. This sin I value you have to take, and sin theta value you have to put, and with that you have to find the sin R. So like this way you have to find the answer. Okay? Okay, now in this your 10th standard such things are not there. Only you have to remember this equation. Sin I upon sin R is equal to constant. This is the Snell's law. Okay, dear students. And further, all the details we will discuss. The following are the laws of refraction of light. Dear students, you know that what do you mean by refraction of light? These are the laws. Okay, what is the law says? The incident ray, the refracted ray, and the normal to the interface. Interface means the point of interconnection of two transparent media at the point of the incidence all lie in the same plane. In short way, you can say that the incident ray, the refracted ray, and the normal at the point of the incidence all lie in the same plane. Okay. Now, that you have seen earlier explanation also. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. See, second one. The ratio of sine of angle of incidence. See, sine of angle of incidence and the sine of R is constant for the light of the given color and for the given pair of media. So this law is also called as Snell's law. Very important, very important. So remember everyone. Okay, remember all. If I is the angle of incident and R is the angle of refraction, then sin I is equal to sin R is equal to constant. See, dear students, here you not to find the ratio of the sin and sin R. So you have to find the sin value that you are getting from the sin theta, cos theta, tan theta you have studied, in the 10th standard, in the trigonometry. So that value you have to put. But here you not only have to remember this formula. So that all the calculation will be in the 12th standard you are doing. Okay, only remember sin I and sin R is equal to constant. This constant value is called as refractive index. So what is the refractive index? The value of this is called as the refractive index. This refractive index is taken as, referred as the second medium with respect to the first. Second medium with respect to the first one. Okay students, now we'll see, move on the refractive index. What is refractive index? See, you have already studied. So already studied that the ray of the light that travels obliquely means just what you are saying, bending obliquely from one transparent medium to the another, will change its direction in the second medium. From the first medium to the second medium, the direction changes. The extent of that change in the direction that takes place in the given pair media may be expressed in the terms of the refractive index. See, students, the extent of the change in the direction of the light that takes place in the given pair of the media may be expressed in the terms of refractive index and the constant appearing of the right hand side. See, the constant appearing in the right hand side. Okay. Now, the value light travels, okay, right hand side. The refractive index can be linked to an important physical quantity, the relative speed of the propagation of the light in the different media. See, the refractive index is linked to an important physical quantity of the speed of the propagation of the light. So it depends upon the speed of the propagation of the light in the different media. It turns out that light propagates with different speeds in the different media. So light travels fastest in vacuum with speed of, say, this is very important, 3 multiplied by 10 raised to 8 meter per second. Okay, it is in the air, the speed of the light is only marginally less. So you can say vacuum and air both are same. So 3 multiplied by 10 raised to 8 meter per second. But compared to that in the vacuum, it reduces considerably in the glass and water. So in glass and water it is so less. So if we are asking the speed of the light, you can say 3 multiplied by 10 raised to meter per second, vacuum as well as air both. The value of the refractive index for a given pair of media depends upon the speed of the light. So this already you are knowing. The value depends upon the speed of the light in the two media as the given below. Now you see, consider a ray of light traveling from the medium 1 into the medium 2 as shown in the figure here 10.11. See, look the 10.11. See, medium 1, so this is medium 1 and this is medium 2. Now what it says, medium 1 and 2 as shown in the figure, let V1 be the speed of the light in the medium 1. See, medium 1, V1 and V2 be the speed of the medium 2. So here medium 2 is V2. Okay. The refractive index of medium 2 in medium 2 with the respective of medium 1 is given by the ratio. See, this is given by the ratio of This is given by the ratio. See now, the refractive index of medium 2 with respect to the medium 1 is given by the ratio the speed of the light in the medium 1 and the speed of the light in the medium 2. Okay, speed of the speed of the light of medium 1 and speed of the light of medium 2. This is usually represented by the symbol N21. See, look here now, this is usually represented by the symbol of N21, N21. So, refractive index of this can be represented. How you have to read this? N21, the refractive index of 2 with respect to the 1. How to read? Refractive index of 2 with respect to the 1 is equal to speed of the light of the medium 1 divided by speed of the light of the medium 2, or is equal to V upon V2. By the same argument, the refractive index of medium 1, if you are going to find with respect to the 2, it is represented as N2. So what you have to write here? N12. It is given when 1, 2. It means the refractive index of medium 1 with respect to the 2. With respect to 2 you are saying. Okay, so then N12 is equal to speed of the light in the medium 2 upon speed of the light in the medium 1. So V2 upon V1. Okay, see, this is the of medium 1 and medium 2. So V1 and upon V2. Okay, see now the light here, the light rays when enters from medium 1 to medium 2, slightly it bends, and this one is normal. Okay, now if medium 1 is vacuum or air, if the medium 1 is vacuum air, then the refractive index of medium 2 is considered with respect to the vacuum. The refractive index of medium 2 is considered as refractive with respect to the vacuum. So this is called as absolute refractive index of medium. So this is called as absolute refractive index of medium. It is represented as N2. What it is represented? N2. So this is also so important definition. What is meant by absolute refractive index? Okay. Now if C is the speed of the light in the air and V is the speed of the light in the medium, see, if C is the speed of the light in the air and V is the speed of the light in the medium, then the refractive index of medium Nm. See, refractive index of medium is speed of the light in the air divided by speed of the light in the medium. So C upon V you have to write, C upon V. Okay, the absolute refractive index of medium is simply called as refractive index also. This is called as what you are saying, refractive index. The refractive index of several media is given here. So you know that the refractive index of water is NW 1.33 is given. This means that the ratio of the speed of the light in the air and the speed of the light in the water is equal to 1.33. Similarly, the refractive index of crown glass is Ng 1.52. Okay. However, dear students, you need no need of memorizing the table. See, no need of memorize the data. So here all the data are given. This is no need of memorizing. It is given in the, suppose if it is asking in the examination, only remember water and bus. Okay, water, other things no need. And these tables here, ice, water, kerosene 1.44, fuel 1.46, turpentine 1.47, benzene 1.50. See, all these are given. These are all given to you in examination, but only remember water. Okay, and kerosene is 1.44. See, dear students, here you have to remember an optical denser medium may not possess greater mass density. See, these are all optical density we are saying, optical density. So that you will learn. For example, kerosene having higher refractive index. You know that the mass of density is water is more than the kerosene. That is why kerosene is floating on water. But here you see, but here what is there? But here kerosene having higher dense refractive index. Why? Because, see, look here now. Kerosene is 1.44, water is only 1.33. So it does not depends upon the mass. See here, that is why given an optical denser medium may not possess greater mass density. It does not depends upon the greater mass density. For example, kerosene having higher refractive index, it is optically denser than the water. Optically denser than the water. So although its mass density is less than the water, but its mass density is less than the water, but here optical denser than the water, optically denser than water. Okay, now we'll see this yellow colored box. See here given the optical density is given, optical density. See, the ability of the medium to refract light is also expressed in the terms of its optical density. See, optical density is given. The optical density has a definite connotation, definite meaning. It has it has a separate meaning, definite meaning. Okay, it is not the same as the mass density. It has some other meaning will be there. It is not, does not, that mass density is different. We have been using the terms rarer medium and denser medium. So you know that rarer medium and denser medium, it actually means optically rarer medium and optically denser medium respectively. So actually what we are saying, optically rarer medium and optically denser medium. We can say that when medium is optically denser than the other, you can say that in comparing the two media, the one with the larger refractive index is optically denser medium than the other. See, the optically denser medium is the larger than the other. The other medium of the lower refractive index is optically rarer. See, the medium of lower refractive index is optically rarer. The medium of larger refractive index is optically denser. Okay, students, see, okay. The other medium is, okay, the speed of the light is higher in the rarer medium than the denser medium. So dear students, remember that the speed of the light is where? Higher in the rarer medium than a denser medium. Thus, a ray of light traveling from a rarer medium to the denser medium slows down and bends towards the normal. Try to understand here, the rays of the light is traveling from rarer to the denser medium slows down. So its velocity slow down, that's why bent towards the normal. But when travels from the denser medium to the rarer medium, it speeds up and bent away from the normal. So here, when rarer to the denser to the rarer medium, it bent away from the normal. Okay, dear students. Thank you for joining us.